Today I start problem based on Lissajous pattern. So very important for the GATE examination or any competition examination. So Lissajous pattern, in the last class I have discussed the Lissajous pattern is used for the measurement of sinusoidal frequency of any sinusoidal signal or any signal, frequency of any signal or phase difference between the two sinusoidal signals. So first problem is based on how to find out the phase difference. So in the last class we discussed for the measurement of phase difference, the two signals that we applied on the X plate and Y plate must be of same frequency, and if there is a zero phase difference, then a straight line will appear. If there is a phase difference from 0 to 90 degree, then ellipse will appear in first and third quadrant, whose major axis is along the first and third quadrant. And if the phase difference is 90 degree, then a circle, the CRO shows a circle, and if the phase difference from 90 to 180 degree, then again CRO trace ellipse that major axis along second and fourth quadrant. And the angle between two sinusoidal signal depends on the value cut the ellipse along the y-axis and along the x-axis. That means sin phi is equal to y1 by y2, where y1 is the minimum value that cut along the x-axis, along the y-axis, and y2 is the maximum value along the y-axis. So first case, a problem is like that. This case shown in the figure, display Lissajous pattern for case where voltage of same frequency of different phase are connected to Y and X plate of oscilloscope. Find the phase difference of these cases. So first, we observe that the pattern along the CRO is straight line, and a straight line is along the first and third quadrant. So directly you can say that the phase difference is 0 degree. Again, in the second problem, ellipse will appear that major axis of ellipse is along the first and third quadrant. So now we have to find out the phase difference between the two sinusoidal signal. So we have to measure the y1 and y2. So according to the formula that I have discussed, y1 becomes, y1 is the value that cut along the y-axis, and y2 is the maximum value of ellipse. So from the figure, y1 is equal to 2.5 and y2 is equal to 5 unit along in a CRO. So sin phi is equal to y1 by y2, that means is equal to 2.5 by 5, 1 by 2. So phi is equal to 30 degree because the major axis is along in the first and third quadrant. Next, the ellipse. In the next problem, again ellipse, first and third quadrant. So we have to find out the y1 value of y1 and y2. y1 is the length that cut the ellipse along the y-axis, and y2 is the value of maximum value of length along the y-axis. That means the tangent touch the ellipse from 0 to that tangent. So from the figure, y1 is equal to along 3.5, about 3.5, and y2 is equal to 5. So sin phi is equal to y1 minus y1 by y2. That means 3.5 by 5. That means almost equal to 1 by root 2. That means phi is equal to 45 degree, as the major axis is lie along first and third quadrant. And next problem, suppose the ellipse. In the next problem, ellipse but the ellipse lie in the second and fourth quadrant. So again we have to measure the cut point along the y-axis. So the cut point along the y-axis is y1 is equal to 2.5 and y2 is equal to 5. So again phi is equal to 2.5 by 5, that means 0.5. So but the major axis of ellipse is along the second and fourth quadrant. So phase angle is 180 minus 30 degree, that means 150 degree, because the major axis lie in the second and fourth quadrant. So in this way we can find out the phase difference between two sinusoidal signal using Lissajous pattern. Next we have to find out the frequency using Lissajous pattern. So in the last class we discussed the ratio of frequency depends on the tangent touch. Suppose if you apply the two sinusoidal signal, one having known frequency and another having unknown frequency on the CRO. Suppose along the x-axis we applied one signal having known frequency, and along the y-axis is if you apply the signal, so there is a so Lissajous pattern will appear on the CRO, and the number of tangent along the y-axis and divided by number of tangent along the x-axis decide the ratio of frequency along y-axis and x-axis. That in the last class we have discussed the formula. So we have to carefully solve this problem. The most popular type of question come across in the GATE examination. So one of the example is in the GATE 2004. A Lissajous pattern as shown in the figure below observed on the screen of the CRO when voltage of frequency fx and fy are applied to the x plate and y plate respectively. Then what is the ratio of fx and fy? And we have to find out using the Lissajous pattern. That means the result of Lissajous pattern across the CRO is shown in the figure. And suppose we have applied one sinusoidal signal along x-axis and along y-axis. So the number of tangent fy and fx. So number of tangent along horizontal axis decide the frequency along the y-axis, and number of tangent along the vertical line decide the frequency of x-axis. So that means the ratio of fx by fy, the frequency along x divided by frequency along y. So frequency along x decide by the number of tangent touch the vertical line, that means 1, and frequency along y-axis decide by the horizontal number of tangent. So if you draw the tangent, then you observe in the horizontal line there is a one full tangent and one half tangent. So that's why we have drawn 3 by 2. So fx by fy is equal to 2 by 3. So ratio is equal to fx is to fy is equal to 2:3. So in this way you can measure the frequency using Lissajous pattern. Again in the problem number 3, a stationary closed Lissajous pattern on the CRO has 3 horizontal tangent and 2 vertical tangent for the horizontal input with the frequency 3 kHz. Find the frequency of vertical input. That means again we have applied 2 sinusoidal signal, one having known frequency, another having unknown frequency. So along the in a CRO, Lissajous pattern have 3 horizontal tangent and 2 vertical tangent, and horizontal inputs having frequency is equal to 3 kHz. So we have to again we draw the that means suppose fx is equal to the horizontal frequency is equal to 3 kHz, and we have to find out the frequency along y-axis, that means along the along the horizontal axis. So frequency of y divided by frequency of x, that means the ratio of y divided by ratio of x is equal to number of tangent along the horizontal line divided by number of tangent at vertical line, because frequency along y-axis decided by number of tangent along horizontal line, and frequency along x-axis decided by the number of tangent along vertical line. So Fy by Fx is equal to number of tangent along horizontal line divided by number of tangent at vertical line. So you know that. So from the problem, number of tangent is equal to 3 along horizontal line and number of tangent along vertical line is 2. So 3 by 2, as you know, the frequency along x-axis is equal to 3 kHz. So unknown frequency is equal to 4.5 kHz. So in this way you can measure the unknown frequency using Lissajous pattern. Again the problem number 3. A screen pattern CRO shown in the figure below obtained when the sine wave signal of unknown frequency is connected to the vertical input terminal, and at the same time at 600 Hz sine wave voltage is connected to the horizontal input. So we have to find out the unknown frequency, that means Fy. So from the problem, first we have to find out the data which is given in the question. So according to the problem, the sine wave is applied across the unknown frequency, sine wave of unknown frequency is applied across the vertical input, that means along y-axis, and a known frequency sinusoidal signal is applied across horizontal line. So Fy by Fx, so Fy decided by the number of tangent along horizontal line, and Fx is decided by number of tangent along vertical line. So from the diagram, the full wave number of horizontal tangent is 2 and number of vertical tangent is 3. Then Fy by Fx is equal to 2 by 3 and Fx is given as 600. So Fy is equal to 400 kHz. So in this way we can measure unknown frequency using Lissajous pattern. Again, suppose one of the example, there is one Lissajous pattern. So we have to find out the ratio between Fx and Fy. So suppose we have applied 2 sinusoidal signal having frequency Fy and Fx. So Fy is by Fx is equal to number of horizontal tangent by number of vertical tangent. Number of horizontal tangents is 1 full and 1 half, that means 3 by 2, and number of vertical tangent is only 1 cycle. So number of fy by fx is equal to 3 by 2 divided by 1. So ratio between fy and fx is equal to 3 by 2. So this is one of the most important topic for the GATE examination. So I think you have to practice on more question. More question you needed to be practiced, so that you can understand how the phase angle and frequency are measured using Lissajous pattern. So if you have any doubt, so you, during the problem solving, so you can directly contact with me. I have discussed some question so that you can understand the concept how the Lissajous pattern is useful for the measurement of phase and frequency. Thank you.